Good morning. This lesson is for my Trig-Precalc class. This is for Chapter 3, Lesson 2. But before I get started, I want to say I hope everyone is doing okay out there. We have one goal on this lesson, and it's finding known coordinates on the unit circle using length. It's also finding angle measures. Remember, coordinates on the unit circle represent angle measures. And so I'm going to show you a different way to find those coordinates. So let's just start off with a review. We're going to need to know how to calculate the length around the circle, because that's how we're going to find the coordinates, is we're going to find it based on length. And the circumference of a circle is the length around the circle. So if I use this formula or this formula, I can actually calculate how far it is around the circle, right? So circumference is equal to 2 times pi times the radius, or circumference is equal to the diameter times pi. The diameter is 2 times the radius. All right, so now 360 degrees is also considered a full circle, right? So we can say that 360 degrees is equal to 2 pi r. Now, I could have also said 360 degrees is equal to diameter times pi, but I'm just going to use this formula. We'll get the same result either way, but let's just move forward. We're dealing with a unit circle, so that means that the radius is 1, and when I plug in the radius is 1 into this formula, I get 360 degrees is equal to 2 pi. All right, so in the first lesson, we made 2 triangles and used their side lengths to find the ordered pairs that would represent that angle measure. So an example of this ordered pair, 1/2, comma, radical 3/2, that represents 60 degrees, and I found that, excuse me, using this triangle, the 30, 60, 90, where the 60-degree angle was part of the origin. The horizontal length was 1/2, the vertical length is square root of 3/2. That's why this ordered pair represents 60 degrees. So here I'm finding, or I'm representing angle measures as ordered pairs. All right, I'm finding it by, I found this point on the unit circle by using this angle. Now, I want to find this point on the unit circle by using the length on the unit circle. So what I need to do is I need to go back to this equation, and I'm going to make this equation equal to 60 degrees by dividing both sides by 6. So I know that 60 degrees on the unit circle has a length of pi/3, meaning for me to get to 60 degrees, I have to travel a length of pi/3. If I want to get to 120 degrees, I have to travel another length of pi/3, which is 2 pi/3. If I want to go another 60 degrees, I have to travel another pi/3, and that actually takes me to 180 degrees. So we can think of 60 degrees as 1/2, comma, square root of 3/2, or we can think of 60 degrees as a length of pi/3 on the unit circle. I can think of 120 degrees, and I hope that you can see this okay. I can think of 120 degrees as 2 lengths of pi/3, or as 2 pi/3. And so I'm going to pause the video here and show you how I'd actually work my way around the unit circle. But hopefully this is making sense. Again, I can find points on the unit circle by the angle measure that I created, or I can find it by the length, right? And so again, I wanted 60-degree angles, and I could get that by dividing this by 6. And that tells me for every length pi/3 that I go, I have created a 60-degree angle. So I'm going to pause this, and I'll be back. I'm back. All right, so let's continue with this lesson. Now I've drawn the unit circle, and I've only included locations in the unit circle that are represented by multiples of 60 degrees. So 0 degrees, 60 degrees, 120 degrees is this location, 180 degrees is this location, 240 degrees is this location, 300 degrees is this location, and 360 degrees is this location. And so let me again remind you that 60 degrees on the unit circle is the same as traveling a length of pi over 3. So here I can talk about 60 degrees as this ordered pair. I could also talk about it being 60 degrees, or I can talk about it as traveling a length of, and I don't know what I did with that marker, the only good marker that I have, oh well, I hid it from myself, so this will have to make do. So for every length of pi over 3 I travel, I've gone 60 degrees. So for me to get to this point, I have to travel a length of pi over 3. Now I need to travel another length of pi over 3, or 2 lengths of pi over 3, to get to 120 degrees. So 120 degrees is 2 lengths of pi over 3. So if I travel another pi over 3 distance, I can think about being at 120 degrees, or this ordered pair, or traveling this length. Okay, so I have 3 ways that I'm representing an angle. I'm representing an angle as the coordinates, the angle, or the length that I have to travel on the unit circle to get there. To go from 120 degrees to 80 degrees, I need to add another 60 degrees. So again, if I take this and I multiply it by 3, I get 60 times 3. And I have to do that to the other side, and that's pi over 3 times 3. These cancel out, so 180 degrees means that I've traveled a length of pi. So to get to here, I can consider it this order pair 1, 0, or 180 degrees, or I've traveled a length of pi on the unit circle. Okay, so that's three lengths of pi over 3, or adding 3 60-degree angles to get to this point. If I add another 60 degrees, so we're at 4, right? So 4 times 60, that'll get me to 240 degrees. And the same on the other side, 4 times pi over 3, which is 4 pi over 3. It takes me a length of 4 pi over 3 to get to 240 degrees, or this ordered pair of -1/2, negative square root of 3 over 2, or 4 pi over 3. Again, if I go another pi over 3 in length, that means that I've gone 5 of these, so I'm at 300 degrees, which is the same as 5 pi over 3. Right, so I travel another length of pi over 3. I am here, so this is 5 pi over 3. And again, it's taking me 5 of these pi over 3s to travel this length to get to an angle measure of 300 degrees, or this ordered pair of 1/2 comma negative 3 over 2, negative square root of 3 over 2. And if I travel one more length of pi over 3, I have 6 60 degrees that I've gone, or added 6 60-degree angles and got to 360 degrees. Or I have 6 lengths of pi over 3, right? 6 lengths of pi over 3, that becomes 2 pi. And remember, 2 pi is the same as 360 degrees. So it takes me 6 of these lengths on the circle to go all the way around. Now your homework assignment is you need to figure out for this original equation, and let me find my erasing machine, which is right there. My marker that I'm missing over here. No, it's all the way back there. I see it. I hid it for myself really well. So your next assignment that you guys are going to be asked to do for this assignment, it's not very difficult, is we're going to use our original equation of 360 degrees equal to 2 pi. And you need to figure out what you need to divide this by to get 30 degrees, and also to get 45 degrees. And once you do that, then you're going to know your length that you have to travel around to get to those increments. And I'd like you to fill this in and simplify the fractions as you work your way around. So again, the point of this lesson is I'm really trying to stress the fact that there's multiple ways that I can represent a location on the unit circle. I can talk about it as an ordered pair, I can talk about it as an angle, or I can talk about it as the length that it took me to get to that. They're all interrelated. Alright, so there's multiple ways to represent a location on the unit circle. So hopefully that makes sense. I will see you guys later. Bye-bye. Have a good day.